All right, we're back on area and distance traveled. Here's our second example. And our second example is very similar to the first one in that someone is taking measurements of time, and the intervals now, instead of 3 seconds, are 1.5 seconds apart. So see how I have many more measurements. I have twice the amount of measurements, if you will. In this case, the change in time that I'm taking my measurements is now every 1.5 seconds versus before we took it every 3 seconds. And if you look at it here now, if I count this, I have 1, 2, 3, 4, 5, 6, 7, 8. So I counted all my carrots here. I have 8 rectangles, or double the amount of rectangles, to see if we can find what the distance traveled is. So again, we have this curve, and I'm not even going to do this yet for a minute, but we have an upper sum and a lower sum. And the upper sum, okay, which was our right-hand sum, if you will, okay, or right endpoints. And in this case, it's our overestimate. And the left-hand sum, or the lower sum, we call it the left-hand sum, or we used our left endpoints. And it was an underestimate. So let's look at our picture here. Notice I have many more points, and we're going to do the rectangles again. So let's just do the rectangles, and we'll go back and look at the information. So the first one, the upper sum, we're going to use our right endpoints, and notice our rectangles are now every 1.5 high. So there's 1.5. So I'm just trying to get this kind of set up here, 1.5. All right, so now we're going to use our upper, so we're going to go use this right endpoint and come over and come down, come over and come down. I'm sure yours is going to be a lot nicer than mine. And when I'm done, I should have 8 rectangles. One, 2, 3, 4, 5, 6, 7, 8 rectangles, and we're going to shade them. Okay, so this one's our overestimate. If you can see here, I'm overestimating it just above the curve here, and we drew them. Now let's do our underestimate, or our left-hand sum. So here we're going to start at the left and use that to come over. But before I do that, let me do this, because I'm not going to get them right if I don't. I'm just going every 1.5 seconds. So I'm going to come over and come down. Go to the left, come over, come down, left, come over, come down, left. This takes practice. I used to not be very good at this. There. So I'm using my left hand side, and then we're going to shade that in. You can stop this if you need to kind of do this on your own. So I shaded that one. Okay, so let's kind of go up and see what we did here for numbers. And I kind of did this already, but if you'll notice, the only thing that's different here is I put it afterwards. But here is my change in time, okay, which was 1.5 seconds. And then the upper sum, I'm going to use the right hand side of this. So here's my first rectangle right here. I start here and I come all the way to the end. So if you'll notice, I started at 15 and I came all the way to 32, and I multiplied all of them by, because it's base times height, or velocity times time, okay, to find the distance, and then I'm going to add them all up, and it came up to be 304.5 feet. The lower sum is, you're still going to use your change in time as 1.5, but I'm going to start out here on the left hand side of 10, and I'm going to stop one short, 10 to 31. So here's my 10 to 31, and they're all 1.5 wide, and then that came to 271 feet. Again, our underestimate. And that's what would, the area of all those rectangles added up would come up to be our distance traveled. All right. So when we look at this one, when we compute the upper and lower sum, we find that the estimate of the area under the curve, however, this is only true if the entire curve lies above the x-axis. So again, we have 271.5 feet is the distance here, and we're estimating it. And I want you to see something. The distance between the upper and lower bound, if you will, is about 33 feet between the top, where you're estimating. This is my low estimate and this is my upper estimate. This is about half of what the first example was. And the reason why they're coming closer, of example 1, they're coming closer together is because I'm measuring it more frequently, and as I do this, notice the more rectangles I have, the closer to a curve it's becoming. All right, and I just want you to notice that the more frequent measurements will give you a more accurate measurement. Now, this next example is we're going to talk about oil leaking from a container. And this oil is leaking, and it tells you time in hours, and here's our rate right here. So if I know I multiply this, I'll notice that I'll find out how much oil, the volume of the oil that's leaked out. Okay, so a couple things I want to notice here. All right, suppose the oil leaks from a container at a decreasing rate. Now this makes a difference. Notice the rate is slowing down. Okay, before we talked about an increasing rate. So I'm going to see if we can estimate under the curve. So let's do our carets, and I notice I'm measuring it every 1 second, so my change in time is 1 second. And I have 4 rectangles here, so my n is going to be 4. And we want to know what the maximum amount of oil that's leaked out. Now here is where this change. This is a decreasing function, if you'll notice, because our rate is decreasing. So if you're looking, all right, for an upper estimate, that's the maximum amount, that is going to start on the left. It's going to have to do our left-hand sum, or left endpoints, if you will. Sorry, I can't spell. Left endpoints, because that is going to be the higher estimate. Okay? So when I do that, I'm going to say, okay, it's going to be 1 times 35 plus 1 times 30 plus 1 times 26 plus 1 times 23. Notice I start here and I'm going to here. All right? And when I add that all up, and I notice I'm multiplying all by 1, but that's how wide it is, and I just want you to see, that's 114 liters. Okay? How do I know this? Well, if I take hours, right, and I multiply them by liters per hour, I want you to notice something. They cancel out, and I get liters for an answer. So this tells you the actual amount that's coming out of that tank. And I know it's an upper estimate, okay, so this is upper because it's a decreasing function. Now, if you get mixed up, you can do them both and say, well, this one's higher, but this one's a decreasing function, and this is a larger number, and these are all smaller, so this is going to give you an upper estimate. Again, I can write this as 1 times 35 plus 30 plus 26 plus 23, and you will still get the 114 liters. Okay? Now, what is the minimum amount of oil? Well, the minimum is going to be our right-hand sum, if you will, or our right endpoints. And so that's going to start here at 30 and come to 21, and they're all still 1 wide, so it's 1 times 30 plus 1 times 26 plus 1 times 23 plus 1 times 21. This comes out to be 100 liters, which is our lower bound, if you want the minimum amount. And I can write it again like this. To show you where that comes from. Now let's sketch them both, all right? So we're going to do our upper sum here on the left and our lower sum on the right. So the upper sum, these are all 1 wide, so this makes it nice, starts here at 35, and we're going to come over and down, and then we're going to use this. We're using the left hand side, the left end points, if you will. And you'll notice that this will be a upper estimate because it's a little bit above the curve. Okay? Sketch the lower sum. So the lower sum is going to be our right hand sum in this case. We're going to take the right end point, come over and down. The right end point over and down. Right end point over and down. See how this works? Oops, it's kind of crooked. And then that's the area of these rectangles we found. And this is a little bit of an underestimate, if you will, because there's some gaps. Okay? So there, that shows how to do it with tank. Now there's some more problems here on the next page here. So if we had to guess how much actually leaked out, what would you guess? Well, I'm going to take my upper sum plus my lower sum and basically find the average. Let's divide it by 2. So I'm going to guess roughly that 107 liters leaked out. Okay? And then I want to know, what is my maximum error if I use that to estimate? Well, if my upper sum is 114 and my lower is 100, and I guessed 107, the maximum I could be away from either one is my maximum error would be, in this case, 7 liters, because I'm 7 liters from both sides. I'm 7 liters from here and here. So my maximum error is going to be 7 liters. But it's a pretty good guess because I averaged. It could be as high as 114, it could be as low as 100, and if I guess 107, it's halfway in between, I could be 7 liters off. Okay? So that is this video.